Hello, my name is John Gammon, and the goal of this presentation is a Server Load Balancer 101. It's an introduction to basic load balancing concepts and terminology. I have a variety of different things I want to go through, but to start off, I want to just talk about what we mean by a one-arm mode versus two-arm mode load balancing. And to illustrate that, I got a couple of Visio diagrams I threw together. The one on the left is in two-arm mode, and the one on the right is one-arm mode. The obvious difference here is the load balancer, which is in blue here, in two-arm mode has a front side and a back side. And the front side is where my VIP resides. And the back side is the VLAN where my server pool is. In one-arm mode, I just have a VIP on the front side, and the servers are somewhere else on my network. They're not behind the load balancer. In the case of two-arm mode, my web server default gateway is the load balancer. But in this case, the default gateway is probably a router or a layer 3 switch somewhere in the network. So that's a key difference between the two. This is also referred to on the right as a load balancer on a stick. Now, traffic when it comes into the load balancer, in both cases, with NSX and VCNS, is going to do what's called a full proxy. And what we mean by that is the TCP connection from the client is going to terminate at the VIP, and then a new connection is going to be created on the back side, or in this case on the front side, from the load balancer to the web server, or the real server in the back here. So in this case, hits the VIP, creates a new connection. In this case, it's the same thing. It's going to hit the VIP. A new connection is going to be created. And the key is, because it's a full proxy, the source IP that's going to be seen by the real server is this gateway IP on the load balancer. Or in this case, I probably will see the VIP address that comes into this web server. So if I were to look at a log on this web server or this real server, all the traffic would be coming from the load balancer. I would have no visibility into those client IPs. And that's a problem, because a lot of times a web admin will want to see where the clients are coming from. What's their IP address? There may be security where they want to block certain IPs or something like that. So what we do is we put in an X-forwarded-for header and insert that into the request. So the client makes a request, it hits the VIP, the load balancer inserts a header into the HTTP request and then sends that to the server. And that header that it's going to insert is going to be the IP address of the client. So it might be something like that, gets inserted as a header, and then the web server, I can instruct IIS or Apache or any other web server to log and do policies against that X-forwarded-for instead of the source IP. And this is a new feature. I just wanted to point that out, because this X-forwarded-for header is a new feature in NSX that was not in VCNS. All right, the next topic I want to talk about is SSL termination. It's a pretty quick topic, but it's very important. So, but basically what we're going to do with SSL termination is, if you have traffic coming from a client that is HTTPS, that means it is SSL encrypted, obviously. And when that traffic hits the load balancer encrypted to the VIP on port 443, if I just pass that through, which is what we do in VCNS 5.1, then my load balancer has no visibility to that traffic. I can't see the headers, I can't see the payload. I can't compress traffic, I can't insert headers, I can't do anything like that. So it's nice to be able to terminate at the load balancer. That way you can really manipulate the traffic however you want. You can manipulate that payload however you want before it goes to or from the client. So typically what you'll do with SSL termination, you'll terminate at the load balancer, 443 on the VIP, terminate it, and then you'll go clear text port 80 on the backside of the load balancer. And This is typically what I've seen customers do. They'll do port 80 on the backside, clear text. Sometimes customers will re-encrypt, so they'll decrypt and then re-encrypt on the backside. And that's fine. You can certainly do that. But that does mean that the web server does have to do the encryption and decryption. One of the advantages of doing SSL termination on the load balancer is that I've offloaded that from the web server, and it no longer has to spin cycles doing any of that encryption and decryption. Now, one of the key differences between our solution and a hardware load balancer, and it's probably going to be one of the key competitive differentiators, is that a hardware load balancer does all the SSL encryption and decryption in hardware. So it has specialized ASICs or components, hardware components that actually do the SSL decryption and encryption algorithms at a very high speed, at very high transactions per second. And because we're doing it in software, it's going to be, we're not going to quite have as much throughput on that. So keep that in mind. The other thing I would mention about SSL termination is that you have to worry about keys. So you have to have private keys for the application. Those have to be installed into the load balancer. We have to manage those, and then you're also going to have certificate management as well. So we are greatly complicating the configuration of the VIP, because now we've got to have a way to manage keys. We have to be able to manage certs, and that's a pretty large component of most load balancers is the ease of being able to import those components. Customers for their application will already have keys and certs, and then you have to import those into your load balancer in order to really test it. So, and a lot of times at a proof of concept, you'll actually create those maybe temporary to do the proof of concept. So you wouldn't necessarily import those for that, but once they go into production, they're going to have to be able to import that. Okay, the next topic I want to cover is, if you look here, I want to cover SLB algorithms. So once traffic comes into the VIP, how do I distribute that to my pool? And it's going to be round robin or weighted round robin, possibly, least connections, or there's some various hashes I can do. And these are what I've listed that are supported in NSX. And hopefully that's a complete list. All right, so first things first. Let's talk about round robin. That's definitely the simplest, and that's probably the most common that I've seen personally. So what that means is traffic comes into the VIP from the client and hits the VIP, and then as traffic comes in, we just round robin to the server. So let's say client 1 comes in, I send that to web server 1. Another client comes in, client 2, and I send him to web server 2. Client 3 comes in, I send him to web server 3. And I go back. So next client comes in, I send him to 1. So you just kind of round robin through them. Now there's a concept of what they call weighted round robin. And all that means is that as the connections come in, I have certain weights associated with them. So I might say this particular web server has a weight of 2. And this is a 1, and this is a 1, and all that would mean is that the first connection comes in, I send there, next one comes in, I send there, and then I send there. So basically I'm just saying, as I round robin through these, I'm going to put 2 on that server on the left for every 1 each that I put on these web servers. That's what the weighted means. All right, so that's round robin. That's definitely the simplest. The other one here, least connections. So we talked about earlier that the load balancer is terminating connections here, and then it's creating connections to these web servers on the backside. So it knows exactly how many connections this server has. It knows how many connections this server has. So let's say this server has 800 connections, this one has 900, and this one has 850. What the load balancer is going to do in least connections is, when a new connection comes in, it's going to look at these counts here, and it's going to say, okay, this one has the least, so I'm going to send that connection to here. And so it tries to then balance intelligently so that these are roughly the same number of connections on every server. And you can also do weighted as well. So I could weight these. If I know this web server is more powerful, I could tell it to send more connections to it. And that's part of the configuration with weighted round robin or weighted least connection. The other thing is you may have a lot of connections drop at the exact same time on a particular server, or maybe a server, maybe you took it offline and it's just now coming up online, so it's got 0 connections, and the other servers maybe have 800 each. So the algorithm is smart enough to not just send everything to the new server that's coming online and just flood it. It actually is smart enough to kind of like slowly trickle them in and distribute new connections to the others as well. So if this server went offline and now had 0 connections, I wouldn't just send everything to that server till it got to 900 or whatever. I would just kind of slowly trickle them in. So these algorithms have been tuned and so forth for that purpose. So the other thing is there's various hashes you can do. So you can see here I've got a source IP hash and a URI hash. And what that refers to is when when traffic comes into the VIP, I can look at the source IP of the client, or I can look at the URI that they're requesting. Okay, assuming I have visibility into the traffic, I can see the URI. Assuming, like, for example, for HTTPS, I need to make sure if I'm going to do that, I've terminated the SSL. But what it does is it applies a hashing algorithm to it, and will typically take that IP or that URI, and what will come out of that hashing algorithm is an 8-bit number, or maybe not exactly 8-bit, but it's some. So in this case, if it was an 8-bit number that came out of the hash, it would be a number between 0 and 255, let's say. And then what it does is you can weight these, but it would basically assign a number to each one of these. I don't know the exact math here, but I'm sure this is wrong. But basically, it's going to assign buckets. You can kind of just picture like buckets, and it says anything if anything comes out of this hash that's the number 20. When I do the hash on the load balancer, it's going to send that traffic here. If something came out of the hash that was 240, it would send it here. So it applies a hashing algorithm, gets a number between 0 and 255, distributes that to the servers into these buckets. Now, the range that goes into each of these buckets is going to vary depending on how many servers you have. So if, let's say, I go and I add a new server out here, it's going to create a new bucket, and it's going to redistribute these values that it assigns to them for these buckets. It's going to basically change the numbers that are being used. And this shouldn't be 135, actually. I know it's wrong, but you get the idea. All right, so the next thing I want to talk about is health checking. And this is a mechanism where the load balancer will test the back-end servers, the server pool, and make sure they're available. Because I don't want to send connections to a server if it's down, obviously. There's a lot of different things you can do to test a server. You could do an FTP connection. You could do an SMTP or SIP. And a lot of advanced load balancers have a lot of different protocols they support. I'm focusing on three main topics, because that's what NSX has available. So TCP three-way handshake, HTTP, and then parsing, and then scripting possibly in the future. All right, so let me go back to my diagram here. So I have a connection, or I'm sorry, I have a connection from the load balancer to the real server. So I go test my pool, all the servers in the pool. That test connection we call a probe. And the probe has certain functions, like I want to be able to know what the interval is. I want to know how many failures in a row will mark it as down. Also, how long should it wait for a response to come back? Once I send the request, how long should I wait for the response? So there's a lot of different things you configure as part of that probe initially, and also you're going to tell it what kind of probe it is. So for example, I could have a TCP probe that's going to open up a connection on TCP. Let's say that server's running on port 80. I would open a connection on port 80, do a three-way handshake, which is a send, SYN-ACK, ACK, and then if I got the responses back, I would mark it as up, and if I didn't, I would mark it as unavailable. You could also do a HTTP request, and it could be a simple GET where I just say, okay, send a request. If I get a HTTP response, I'm good, and life is good, and I mark the server as up. The problem is that an application, as we know, is not just the web server or just whatever the application is. It's going to have other things behind it that's connecting to. So maybe there's a database back here or an app server. And that link from the web server to the app server could be down, or maybe my database connection's down, or maybe my database is down. And this Apache service is running, and I'm responding on port 80, or I'm answering HTTP response. Maybe I'm sending back, you know, a 200 OK, even though the page is blank. So there's a lot of scenarios where just doing a simple connection is not enough. So what you want to do at a simple level is be able to parse that HTTP response and look for something on the page. So like maybe I send a request to a home page, I make sure that there's a welcome message on it, or maybe just I send a request to make sure there's an OK response, and then I know that I'm hitting the app server to generate the page and possibly looking at content from the database to confirm that. So that's the parsing capability that I believe we do have in NSX. So that's good. The other thing you want to be able to do typically is script. And the idea is to be able to create complex scenarios where, let's say that I need to authenticate to this web server, and I can log in as a known test user with a password, log into certain pages that I have to get behind authentication. That way I have to script that and then test a sequence of pages, and maybe all 4 pages have to pass before I mark it as up. So this allows you to get much more creative and complex and really make sure that the site is responding, and that way you get notified if it's not, and also take the servers out of the pools as needed if there's problems. So that's pretty much health checking in a nutshell. All right, so the last thing I want to cover is session persistence, and this is just the ability of the load balancer to remember users when they come back to the site for some period of time. And there's a lot of different ways you can do it. You can do source IP, cookie, and SSL session ID. There's other ways, but these are probably what I would say are the most common. And it's easiest if I just illustrate this in the drawing. But the concept of why you need it is that, let's say a user comes in, hits the site, hits the VIP, and we load balance them to server 3. And they are shopping. The classic example is they're at a shopping website, they put things into their cart, and then they walk away and go do something else and come back. Now in that time that they walked away, this connection has timed out. So this is now no longer, these TCP connections have dropped. When the user comes back in, they hit the VIP, and the algorithm now load balances them to server 1. Server 1 has no memory of that user, doesn't know what's in their cart because it was stored on in web server 3, and so the user now has an empty cart and they have to do everything over again. So the way you solve this is pretty easy. You basically, when the user comes in, you create a table that keeps track of that user. So let's say you have server 1, server 2, client 1, client 2, and you just remember where they were located. So when that user gets load balanced to server 3, I look at their client IP as an example and store that in the table. And then if that connection closes and I see a user from the same client IP later, I'll send them back to server 3. Okay? Client IP can be bad to use because there may be several users behind the same proxy, and so I don't have granularity to differentiate the users. So the most common method is to use a cookie. And if you're not familiar with cookies, basically all that means is that when the cookie is something that goes in the header of the HTTP packet. And so when the user hits the site, on the return, I'm going to inject the cookie into the response header, and the browser on the client is going to store that cookie. And that cookie is going to contain all the session information for that user. And so when they come back to the site, I'm going to basically store that cookie, and when I see the same cookie with the session information, I know to send them back to server 3. Okay? I would say it's probably the most common. The only downside would be if cookies were disabled on the browser, which can obviously be a problem for a lot of reasons. And the last one is SSL session ID. And this obviously requires that they're doing SSL. But essentially what it means is that when a user opens up an SSL connection, it's going to assign an ID to that user. And I'm going to store that in my table. And then when the same user opens up a connection, it's going to have the same ID. So when they come back later, I recognize the user because it has the same session ID, and I send them back to the same server. So again, all persistence means is that I am remembering where I sent them before, and I make sure the load balancer sends them to the same place every time going forward.